All right, thanks so much. Thank you, Ron, for the opportunity to present today. Always a pleasure to present at your forums. And the topic today is database versus data lake versus data warehouse, and then analytics today. So starting with what is a database? So the definition of database by Merriam-Webster dictionaries is usually a large collection of data organized especially for, I think we are missing a part of this, for rapid retrieval and for reporting. So this was the definition which I found on what do you say from Webster Dictionary, but really the foundation of database was laid back in June 1970, where E.F. Codd, researching at IBM Research Lab in San Jose, wrote a white paper, a relational model of data for large shared data banks. That paper talked about techniques to divorce data from application, because before that the data was tightly integrated with applications, and if at all there was any kind of change in the underlying data, the application would get impacted. So some concepts from that white paper were taken by Larry Ellison, and he came and uh, built a database, Oracle, which was released in 1977. And that set the foundation for subsequent databases released by other companies. Teradata came up with their database in 1979. IBM came up with their DB2 in 1983. And Microsoft came up with SQL Server in 1989. Hard to believe it is already 30 years, but SQL Server in Microsoft, the SQL Server environment is pretty much everywhere even today. So we have SQL Server on premises, the SQL Server 2019 released on 30 years of SQL Server. We have SQL available on Linux. We have SQL on containers. We have SQL on Kubernetes. Is there a way I could minimize this? This is maybe blocking the view here. Or I move it down. Okay. And then we have SQL, this platform we have, if you're thinking Azure, moving to Azure, if you want to keep your SQL platform there, you have the SQL available on virtual machines. We have SQL managed instances, best suited for your lift and shift of your migrations to cloud. But we also have Azure SQL Database, which is suitable for your what do you call modern cloud applications. And we also have this elastic pools. It's available in different flavors, the elastic pool, the hyperscale, and serverless option. And we also have the SQL database available on Edge to support your to support data and machine learning applications on IoT Edge. Going a little further into options, because this is a question which comes up very frequently in my conversations with customers, as to when do you decide what you want to do when you are moving to Azure. So if a customer is looking for exactly similar environment as they have on-prem, we suggest going to virtual machine if they are looking to manage the hardware as they were doing on-prem. If you want to work with the OS, managing the operating system and SQL Server on your own, and you want to do the monitoring and HADR, exactly like same, you get a similar environment on Azure. That's when we say go for SQL Server on Azure Virtual Machine. But if you want a full on-prem environment where the management you want it to be offloaded, the management and patching and backups to be offloaded to Azure, that's when we propose going for Azure's database managed instance, the SQL database managed instance. But if you are on a customer who is working on applications where you are building web applications, or all you care is a backend database, in that case, you just go and use an Azure SQL database, which is again available in multiple flavors. It could be a single database. It could be a group of databases sharing the elastic pool, where you could combine the compute resources and have that available to a group of databases. And then you could also go hyperscale, where you have the capability to scale up the database to 100 terabytes in size. And we also have the serverless option, where there are database applications like maybe expense application. In an organization, how many times do you submit expenses? Once or twice a month for approvals. So the database comes up when needed, and then you get your work done and the database shuts down. So we have these 4 flavors available on Azure as well. So when we talk about Azure, going a little more detail, if somebody is just looking to do a lift and shift to Azure, these are the 2 options, the SQL virtual machines or managed instances. Advantage of SQL virtual machines, when do customers use it? It's when they have legacy applications where you need to lift and shift and do not want to make a lot of changes, which might be necessary, exactly same version of Azure SQL database than what is available on managed instance. We always have the latest version available. So in that case, you go for SQL virtual machines. But if you are up to date and you want to migrate to cloud and have the management left to Azure, we go for managed instances. This is also what you call another the SQL environment, which we already talked about. So coming to SQL MI or database, yes.
One thing, I'm hearing just a little bit of background noise. I'm not sure anyone else is. If there's some, I don't know, door that's opened, or maybe you could turn off any speakers in the background. Just want to make sure this is such important content. I don't want to get it lost.
Right. Yes. There is some lawn mowing going outside across the street, and so it's a bad timing when I started talking and they started here. Hopefully, in 5 minutes they should be out of here.
Okay. All right. Welcome to the world of online seminars.
All right. Yeah.
Okay. That's fine. Just try and speak a little bit louder if at all possible, because this is such good stuff and I don't want to have anyone miss out on it.
Right, exactly. No, I'm sorry about that. The others people are just this. Hopefully they'll move away. But yes, this is a conversation I had numerous times in the last year, where we had to help customers decide between the 2 options we have. Both of them are PaaS options. Both of them meet different needs of the customer. It's just what you go for. So SQL managed instance, fully managed, you have the business critical options in both of them. Only difference is you get a native network here with Azure SQL managed instance. You get your own, you can do the cross database queries, you have your own agent, you can send DBMS mails, you have the ability to do replication and pretty much all the stuff you were able to do on on-prem. But Azure SQL database is, again, you get most of the options, but you don't get very few things. I would say if you do not care about them, then this is the way to go for modern application development. You get serverless compute, you get private link support, and it's, again, a fully managed service. So with this, I move to the next topic on the discussion, where we talk about data warehouse. So data warehouse is the next progression from databases. So what really happened is once databases were there available they're in the market, what businesses started doing is operational systems came into fore, where every organization had operational system for managing payroll, for managing inventory, or managing some POS data. So when you go by the definition of data warehouse, it's a repository of integrated data from one or disparate sources. But the data is now become a business asset now, because you're combining data from operational systems and putting it one place to consume for different departments and to be make it available for analysis and reporting. So I have worked with the data warehouse, where just the data warehouse was the end goal, where it would serve all the reporting needs. But I have also seen data warehouses spin into data marts, where they and reason for doing that is when the departments didn't want to share some information across the organization, they wanted to keep it in their own in their own environment. That's when they will extract the data from the required data from the data warehouse and combine it with their local data and still make it available for analysis and reporting and data mining. So data warehouses, the needs were different. The needs were not just to support an application, but the needs were at a higher level. There was an underlying business goal to improve profitability with their investments, or trying to see what was missing, or identifying some flaws or gaps in their data which could be addressed. So more of a business focus. And this started, we needed a different hardware now when we start working with a lot more data, because now you need systems with a bigger compute and bigger storage capabilities. And that's when Teradata and Oracle and SQL Server all came up with very custom-built appliances to handle these kind of business problems. So that data, which could be housed in these appliances, tightly integrated network, and it's more read-focused. All right, so this is the foundation. Here, this is a common question asked even today, and I thought I'll put it into a tabular form so we can talk through this. Because databases typically are for real-time business operations. So you go to a bank, you go and or you log in online, looking at your bank balance or looking at it. It's a real-time operation. You withdraw or move money from account A to B. That's real-time. But data warehouses are really not real-time. It happens after you have done real-time operations. So it's post-real-time, or after an event has happened. And mostly on databases, you have a single line or smaller transactions. But data warehouses, you have big or bulk data loads, large aggregations happening on that data. So typically, like when you are trying to design for those, they have to be kept separate, because that again is a question that should we have both of them together? Yes, you are using SQL, you can do it together, but to avoid this transaction where you have small transactions and big transactions impacting the same system, it's ideal to keep them separate. And if you look at a database, it requires data validation queries. You're logging in to check out something from Amazon. There is a data validation happening as to if you're asking for a larger quantity, if it's available or not. But data warehouse, there is no real-time validation. And so the design. So what I'm getting to is the underlying design principles are very different when you work with databases and data warehouses. Databases support thousands of concurrent queries. These queries are like pretty much single row selects, looking for your bank balance, looking for availability of a stock item. It's small queries, just targeting few. When I say small queries, means targeting 1 or 2 rows or records. But when you go to data warehouses, they are looking, when they are trying to run big scans, there are not many queries running. There'll be few users who are running their analytics on a data warehouse, because now they're reading across millions of transactions, trying to work through them. And the databases are optimized for writes, and data warehouses are optimized for reads. What that means is, when you're optimized for write, the data model has to be different. Most frequently seen, what is optimized for write is a third normal form. But when you say optimized for reads, the data warehouse, typically it is in a denormalized format, or it is in a star schema format. And we talk of applications, they're database, they're application oriented. They try to meet needs of an application. data warehouse, we talked about it. It meets the needs of the business. It could be anything like whatever the business corporate strategy is to build the data warehouse for, that is what it is oriented for. So again, I wanted to bring this again in front of everyone that there are two approaches to get value out of data. One is the top-down approach or a bottom-up. So the top-down approach is what we say when we know exactly what questions we want to ask, and we know what work has to be done to get those questions to be answered, and we know what are all our data sources, where the data is coming from, what we need to, relations and models we need to build. That's the top-down approach. And that is something which we use when we are trying to build a data warehouse. What kind of value does it give you? Because we are now storing historical data, you can answer these questions like, what happened? Why did it happen? You're able to do diagnostics on that data. You're able to figure out exactly what do you call, what was the trend? What happened? Like, okay, we ran a promotion. Did it run good, or did it outperform our expectations, or did it underperform? Then you say, why did that happen? So we have capability to do these kind of analytics. But the other kind of approach to look at your data is when you go in just totally blank. You do not know what to do with it. You are put in front of data and you don't know what information is in there. You are on an exploratory mission there. You're looking at, okay, from this haystack, where do I find the needle I'm looking for? So there is a lot of exploration, discovery, and because you do not know what you are getting in front of, the modeling happens at a later stage. So this totally defines, this picture defines the two approaches, and they both are so different that our organizations can either handle one or the two with our existing systems. So the data warehouse is focused on the green side of this graph, where we say that you can do diagnostic and descriptive analytics. And if you see that, if I'm just focused on that graph, the more you move towards right, the difficulty to get all the analytics together increases. And similarly, the value which you derive by getting to all four stages of analytics is a lot more business value, and every organization now wants to get there. So what is Microsoft doing? Okay, there is one more slide where we talk about what the data warehouse top-down approach is. You know upfront what your data sources are, you know what your ETL would look like, you know how you want the data model to be laid out, and you know beforehand what your dashboards or reporting is going to be like. So the people who are trying to get into building this data warehouse understand the corporate strategy, and they gather requirements to meet the needs of the business. And we have business requirements laid out, we have technical requirements laid out, and that's where starts the data warehouse project. You set up the infrastructure, you get the hardware, you get the ETL design, the physical design is ready, and there comes data warehouse. Even though I put it in a slide in 2 minutes, covered it, data warehouse cycles are typically 18 to 24 or even 36 months, where I have worked on 4 of them. It takes time, because to gather an overall business requirement, to work through it, to model it, even if you do the agile approach, you try to go with set small goals, the full data warehouse does take 18 months minimum. That's what I have found. So, what is Microsoft doing here? What we have here is created something where if you are doing a similar, you're on the similar trajectory of data warehouse, we have Azure Synapse available for you, which is an MPV platform. It can scale up to terabytes and petabytes of data. In fact, we have GigaOM who did their They ran their benchmark on the petabyte size of Azure Synapse as well, just to say that this platform works to the petabyte scale. But what Azure Synapse has in it is the ability to independently scale your compute and storage. And along with that independence, it also adds everything like the integration, like ETL pipeline, just like on-prem SQL databases, we used to have SSIS packages. It was refactored and rebuilt into Azure Data Factory on Azure to be able to give more compute and scalable compute when we try to work on cloud. That functionality has been integrated within Synapse. So the integration tools, the orchestration capability to bring data from on-premise, from cloud, SaaS, or streaming, we have close to 100 connectors from which you can bring the data to Synapse within the SQL pool. So if I go, if you look at my analytic runtimes row, we have two analytic runtimes showing here, which is the SQL runtime for users who are familiar with, who are working with current data warehouses, are familiar with SQL. And we also have a Spark runtime, and I'll be talking about it in the next in the analytics section. But we have a Spark runtime, we have SQL runtime, and we have one more, which is the serverless runtime. It's the ability to do serverless SQL on top of your data sitting in your native format. And on the right side, it is a full integration platform end to end. So even the visualization, Power BI native integration is built into Synapse. We have Azure Machine Learning integration built into Synapse. So any data sitting within the Synapse workspace, it be that data lake or within SQL environment or Spark environment, integrates with Azure machine learning models, and you can start scoring and building models and accessing them directly real time in Power BI. And the other capability we have is to share the data which has been in this environment using Azure Data Share. So Azure Data Share is the ability to share data. It's if I have to use the give an analogy to this, that it's equivalent to having an FTP server on Azure, I would say, and you can with more capabilities here. You do not have any limits posed on it. You can share data instantaneously. You can set up snapshots. Plus, you know who the data is coming from and who you shared the data with. And you can also set up a timeline as to you want to share those data for 7 days. It'll automatically stop that data share after that time. So data share is a new service in itself, very popular for building data consortiums, but all of them integrate very well with our this new platform, Azure Synapse. So moving to the next section on Azure Data Lake, here I have this is another storage platform, a really important one when we go to Azure. And this is an answer to the modern data platform, which we all have, every organization is going through. So when we started working with data, if we talk about databases, we were in the inner circle. We were dealing with, at the most, gigabytes of data. The data was very structured. It would come in batches. It would come in maybe 1 or 2 batches a day. But then as time went on, we went and expanded our inner circle. And across the 3 dimensions where we are looking at, the data volume grew. The velocity, yes, we started getting a lot more batches to come into our organization. And variety, yes. We were still dealing with structured data for a long time, but as time went on, unstructured data after the turn of the century, that started making its presence, and it was a challenge to how do you not account for so much data which is coming into your business, and how could you ignore the indicators which are sitting in that data? How do you store it? So that's where, and this data is still relevant to continually answer all the questions which we had for analytics, like what happened in the past, what is happening now, what is going to happen. So this is going into that prediction capability close to real time, right? So if you look at it, this graph, you can talk about it for hours going into any use case, but this is really like it says that every dimension of data is constantly expanding, it's still expanding, and we are coming up with solutions to that. Well, anyway, I bring back this chart again and trying to bring up the fact that what we will be focusing in this section is on the left side, because really when you're dealing with a vast amount of data, all you care about how to store it first, and then you care about, okay, what is in that data, and then you care about like, okay, how do we build this extra capability here. So data lake definitely uses the bottom-up approach. Your data could be coming from devices, social media, LOB, or web logs. The underlying principle is ingest all data. Regardless, you don't care what the requirements are. You have to have a place to ingest and store all that data in its native format. You do not know the schema definition, and then you do your analysis on it. It could be, the analysis could be batch queries, interactive queries, real-time, machine learning, or data warehouse. So traditionally, how it is done is you have different tools or different ways to handle this, but in the market. So what is really a data lake? It's a repository of data where you can store it in its natural format without altering it. Even if you're altering it or trying to enrich it in some way or transform it, you still need a cheaper way to store it. So it needs to be organized, very structured. And if it is not, it can lead to a data swamp or a data graveyard, which is really a deteriorated data lake, which is either inaccessible or it provides little value to any business. So we don't want to get in there. So we need to see what is best to get the best of data lake and what is best about the other storage system we talked about, data warehouses, to get our businesses value. And if you look at it, underlying data in a data lake, you do not know what is coming in there, but most of the systems, they are like schema on read, and it answers the questions for tomorrow without any limits. Data warehouse, it's schema on write, because you already know that the schema is what the schema looks like. And it's relational, the relationships are known, and it can be part of the data lake. You could land the data to data lake and then take it to the data warehouse. But neither of them are like, okay, I have a data lake, I don't need a data warehouse. Every business has to make that analysis, because in 2010 and later, many businesses gave up data warehouses and went towards data lake, and just to return back to having a data warehouse, because one does not meet all the needs. We have to work with both of them. So what does Microsoft have for data lake? We have a storage layer, which is Azure Data Lake Gen 2 storage, which has Blob storage as the foundation. But back in 2019, February, what we did is we combined two kinds of storage we had. One storage was the Blob storage, where you could go and store any kind of data, video, audio, or files, or queues, or any data coming in any format. But it was not the best place to do your advanced analytics. If you had to work on files and folders, you didn't have a good, you didn't have the performant way of doing it. You had to copy this data to another storage to be able to get those Linux level, low level features of like security, performance, scale, and data governance. So what we did in 2019 is we combined the two storages. All you have is two APIs now. You can either activate that and start using the same storage to do your advanced analytic work, if that is what you are trying to work on. And if you are just using it for blob storage, you can use the same storage. So this was a big change in the way we have, and this is something, a unique differentiator amongst any cloud platforms today, because everywhere there you have to duplicate your storage, but on Azure, just one storage to meet your needs. And Blob Storage has all the what you call capabilities here to be able to replicate your data, to get your data secured and compliant, make it available, scalable, like you do not have limits when you're trying to use the data to ADLS Gen 2. It's open format, third-party integration is available, and you have REST APIs. And also there is data encryption. A 256-bit AES encryption is available for data at rest, and you also support customer encryption keys. For any data in transit, we support that HTTPS protocol to then turn off the HTTP one. And we also have the client-side encryption supported. So with this, we come down to the analytics side, and we come back to Azure Synapse Analytics again. So we talked about data warehouse and data lakes. What this did is, because the tools were so different, the skill sets required were so different for working with data warehouses and working with unstructured data or data sitting in data lake, that we created two kinds of personas in every organization. So there was this persona, business analytics or analyst, business analysts, who would work with relational data. They knew the data had the right kind of security and privacy. They knew it will meet their SLAs. The data was structured. So they dealt with the data warehouse side of things, and they were very comfortable. But then this data science scientist and data science platform grew up in every organization, which was really called the big data platform. It was a exploration platform where data would be the semi-structured or unstructured, and they could do experimentations. But both of them did not kind of converge. And what we did, what Azure and Microsoft did, was we focused on bringing these two worlds together by trying to combine the best of the two worlds, make it easy to use, make it fast exploration capabilities available to us, have the same security and privacy and performance, and be quick to start up. So here again, we come back to Azure Synapse Analytics, and I'll cover things which I didn't cover earlier, that Azure Data Lake is the foundation for Azure Synapse. And the two personas I was talking about are targeted by these two analytic runtimes. The data scientists comfortable with Spark, they can use Spark on top of data lake storage, and the data is all within the confines of the Synapse workspace. So you do not need to do any extra security and settings, and there is an integration within the workspace of Azure Data Lake. And when you talk about SQL, that is available. And the third component, SQL serverless, is where even a business analyst could write SQL on top of Azure of the data sitting in Azure Data Lake storage and build views on it. So you do not need to be a Python or a Scala expert to be able to read the data and to be doing exploratory work. So that is an extra capability which Azure Synapse Analytics provides, and you have everything. And time permitting, I'll show you a quick demo as to how this all comes together. But this is the environment which was released and went GA in last December. And we have had customers just really appreciating this this platform, because it really simplifies things. You do not need to spin up another compute to be able to process your data sitting in the data lake here. So this converges, Synapse also converges all the four analytic platforms. So we come back to it. So now using Azure Synapse Analytics, you could do the top-down what you call approach, and as well as bottom-up approach, both at the same place using the same service. That's why I wanted this. So you, for a business to derive value across all the 4 analytics, this platform provides you everything at one place and has all the inbuilt tools in here, the orchestration, the integration, the visualization, the ability to do advanced AI, machine learning, the way to do notebooks. It's all in here. And it's no longer either or. It's a story of both. You need high value data to be sitting in the data warehouse, high business value, like, okay, 1 year of data or 6 months of data sitting in data warehouse, rest of the data sitting in data lake, because it's still queryable using SQL. So the thing is, it is a world of collaboration. It's a world of working together, and data lake and data warehouse, they work together when you're trying to work with Synapse Analytics. And in terms of when you say an architecture, this becomes an architecture if you do not have any other sources to integrate, because you have the data sitting in the data lake, you have Synapse Analytics to do all your ingestion, your data preparation, your data warehouse, you have the presentation layer, now Power BI integrated, anything more, you have Azure Machine Learning in here. So that is what an architecture if you just have Synapse. But we also try to talk about reference architecture. This is typically like if we alter it for any business needs. But on the left side are all your data sources, the structured, the unstructured, and high velocity data. But this is kind of a reference architecture. If you have other components, like, oh, you have data coming in through Click, or you're using other tools, it can definitely be expanded in this architecture. But I said just with Synapse, you could, if you have your sources on the left, you could build pipelines, ETL process for batch processing, and land the data either in data lake or SQL databases, and then get the data moving all the way to Spark Pool or SQL serverless, and have the data move, get presented on the presentation layer. The top layer I'm talking about is the high velocity layer where you see event hubs. And basically, it's showing this reference architecture shows the Lambda architecture where you have the high moving data needs to be processed in a very differently in this architecture, and that's being accounted for with Event Hub, bringing the data of real time with high velocity, landing it into data lake. And if you want to do quick analytics, you have stream analytics jobs to it, and you can also have your presentation layer, the consumption layer, plug into it to do the presentation. So this is what I was planning to present. Do we have time for me to show the Synapse workspace, Ron?
Sure. Can you, once you like spend 2 or 3, 4 minutes, that would be great.
Okay, I'll do that. A quick show of my Synapse workspace. So this is how, when you land into Azure Synapse, this is our landing UI. And from here, we have, for anybody new wants to learn more about Azure Synapse, we have Knowledge Center, where we have capabilities to learn, like you can use samples immediately, explore sample data with, for instance, Spark. So it'll spin up a Spark cluster and you can start working with that data. But another thing I want to show you is a gallery, which is a lot of information. If you need a data set to work with, a commonly publicly available data sets, we do have that to try your machine learning and other kind of stuff, or doing any advanced analytics. We have Spark notebooks available for you to just click and just deploy and start it and start working with it. For instance, if I have to pick this, it's basically a bankruptcy thing. I won't do that. We don't have much time. But if I open it in a notebook, let me see if it quickly does that. Oh, I didn't associate it. Okay, that's. But here is what it did is I have this notebook opened up, and it is opened up within the Synapse environment, and I'm having to do machine learning. The code is already here. The data set is right here. all I need to do is get a Spark pool configured and pointed to. So I do have a Spark pool, and if I do that, this whole code is available for me to work through it. But going back to my to this gallery, you can go to the Knowledge Center, browse the gallery, and tour the Synapse Studio. And here we have SQL scripts, which you can use as is if you're doing copying data from other environments, like copying Parquet files or exporting Parquet files, or doing what do you call type 2 dimensions, or things like these are like pre-built scripts for you to get started. And similarly, we have pipelines available, like you want to bulk copy, you have to bring data. It's pre-built pipeline. All you need to do is point to just configure it, and this will copy data from Google BigQuery to Azure Data Lake. Copy files to a database. It is a template readily available. All you need to do is point your database and pick the tables. Copy data from Oracle to here. Copy data from multiple files container. You want to do from other areas. So this is there. One thing new which was added last week, and I wanted to show that to you, that we have partner solutions now available as well to Synapse. So Informatica, Incorta, Click, those are also available. But now coming down to the UI, if I go, we have 4 hubs. We have the Data Hub, we have a Develop Hub. When you come to the Data Hub, let me close all windows. So, okay, so here is where when I have my data layer connected, my what do you call, this is my storage account, the ADLS2. If I have a Parquet file, to do this, I would need a Python or something to be able to read this. But now I can just query it, because all I do is right click on it, and I just run the query. And it's this is the serverless piece I wanted to show you, that you could query your data sitting in a native format by running a serverless query. And similarly, you see this data, like in the past, I would have to have my environment write a code at a different environment, but this is the integration point. And if you want to open the same file within a notebook, I could do that right here, load it to a data frame, and here I see it's a notebook environment. So you don't have to leave this UI and all they'll do is attach a Spark pool and start coding in Python, Scala, .NET, or Spark. The other layer here is here is where we have, let me go to all your databases, whether Spark or not. The Spark or the metadata is available for you to query. This is huge, because if there were different environments, you would not know what is sitting in Spark, what is sitting in SQL. But here you have everything available. Your Develop Hub, any SQL scripts you build, you can build them right here. And it could be in your development could happen in SQL, in Notebook, or if you're trying to build ETL pipelines, you're trying to build a Spark definition or a Power BI report, all the development work, this is the integrated UI where you do this. And then this integrate hub is where you deploy, you build your final pipelines. So if you have built a pipeline like copy customer information, now you want to, what do you call, trigger it now, or if you want to build that orchestration piece I was talking about, this is where you define it. Like, okay, if the file gets loaded into a folder, you go and, well, this is like on schedule. You have multiple ways to schedule this. One is based on schedule every day at 12 noon, you want to start it. You can, if you want a job to run every 15 minutes, you can trigger it that way. You can trigger it based on when a file got loaded into a folder, the storage, into a data lake storage. You can do custom events. This is as to however you want to define them. So this is everything is integrated here. So you build the pipelines. Now you want to monitor them. This is where you go and monitor what your pipelines have been submitted. They will show up here. You right click, and anything which has been triggered right away, it'll all show up here. So even you can And other than that, the compute I talked about is scalable to run your ETL jobs. You can use what Azure provisions for you, but you can, if you have big jobs, you can configure your own compute to be able to run your large size jobs. So that is available.
Dee, I think if you could just summarize, because we want to make sure we get to the next speaker. It's so exciting, and I'll make all this content available for downloading.
Yes, sure. I will post. I will share my slide decks with you. I think I didn't do ahead of the session, but this is a UI. All you do is go to Azure portal and you can spin up Azure Synapse and you get access to this UI. This is a great way to get hands-on and start learning it. And this is a good resource here to go to the Knowledge Center and trying it out there. So this is where I would summarize that databases, data warehouses, data lakes, they all grew up, they all kind of expanded at different times, but it is time for everything to come together and for businesses to derive value by having an environment which is able to be an integration point across all these storage platforms.